Okay, get this. What if we could pull gallons of fresh, clean drinking water straight out of thin air? We're talking bone-dry desert air. It sounds like something out of a sci-fi movie, right? Well, it's becoming a reality, fast, and it could honestly change everything.
So today, we're going to dig into a technology that's trying to answer that exact question. We are looking at a completely revolutionary way to get water, not from rivers, not from wells, but from this enormous, invisible reservoir that is literally all around us all the time, the atmosphere.
I mean, this is the big, audacious promise, isn't it? A sustainable supply of fresh water that's not tied to a central grid, that's available pretty much anywhere on the planet. And as you're about to see, it's all thanks to this perfect marriage of crazy smart science and just nature. So let's get into it.
But first, why do we need this so badly? Why is this so urgent? Well, the answer really hits you when you look at the staggering scale of the global water crisis.
Right now, as we speak, 2.2 billion people, that's billion with a B, more than 1 out of every 4 people on Earth, they don't have access to safely managed drinking water. This affects everything: their health, their ability to build a better life, their basic human dignity.
And here's the kicker. The problem is only getting worse. Projections are showing that by 2050, an incredible 5.7 billion people could be living in areas where water is scarce for at least 1 month out of the year. Our old ways of getting water just can't keep up. We absolutely need a radical new plan.
And that brings us to this idea of atmospheric water generation, or AWG for short. Now, the idea itself isn't totally new, but the first attempts, while pretty clever, they ran into a massive deal-breaking flaw.
So the core idea is pretty simple. Let's just tap into the 13 trillion tons of water vapor that's just hanging out in our atmosphere. I mean, it's this huge invisible resource that's always being replenished, and it could be a total lifeline for dry parts of the world. So the first way we figured out how to do this is going to sound super familiar. It works almost exactly like your home air conditioner or a dehumidifier. You just use a fan to pull in some air, you run it over a cold coil to chill it down, and poof, water droplets form, which you can then collect and filter. Simple, right? Well, simple and effective, but only under the right conditions.
And that's where we hit a wall. Just look at that cons column. First off, this old method is an absolute energy hog. It takes a ton of electricity. But here's the real killer. Its performance just tanks in dry air. We're talking below 40% humidity, it pretty much stops working. So it fails in the exact places that need water the most. We needed a breakthrough.
And that breakthrough, it has a name: Metal Organic Frameworks, or for short, just MOFs. And this is where the science gets incredibly cool and the entire game just changes.
So, what are MOFs? You can think of them as a kind of programmable matter. They're these microscopic, crystalline structures built from metals and organic stuff, and they're engineered at the molecular level to have these huge internal surface areas, with pores that can be perfectly tuned for one specific job. The best analogy here is a molecular sponge. But this is a sponge like no other. These MOFs are engineered to be incredibly thirsty for water. I mean, they can be programmed to selectively snatch only water molecules right out of the air, even when the humidity is crazy low, like down to 10%. And here's the magic part. All it takes is a tiny bit of low-grade heat to make the sponge wring itself out and release all the pure water it just collected.
And where do you get a bunch of low-grade heat in the world's driest places? The sun, of course. This creates this absolutely perfect synergy between this super advanced material and the most abundant free energy source on the entire planet.
So let's just put these two technologies side by side. The old way needs high humidity and tons of electricity. The new way, with MOFs, works in extreme dryness and can run on simple, passive heat from the sun. This isn't just a small step up, it's a total game changer. It unlocks water harvesting for the deserts. And this isn't just theory, okay? This is proven. Researchers from UC Berkeley and MIT, they built a prototype. They took it out into the Arizona desert, and they proved it works. They successfully pulled water from the air in ridiculously dry conditions, using nothing but the ambient sunlight to power the whole cycle. So where is this tech making a difference today? Well, while it's still pretty new, these MOF-based water harvesters are already being put to work where they're needed most. Getting water to soldiers in remote areas, helping out in disaster zones after infrastructure goes down, and bringing water independence to off-grid communities.
So what does the future hold? Well, the path ahead looks incredibly bright, but let's be realistic.
There are still a few big hurdles to clear before this tech can become a truly global solution. The biggest challenges right now really boil down to cost and scale. Making these advanced MOF materials is still pretty expensive, and we've got to figure out how to mass produce them efficiently and make sure they can last for years out in harsh environments. But if we can crack that, look at the other side of that coin. The promise is huge. We're talking about a future where communities have a clean, reliable water source that makes them resilient to drought. So the dream of pulling water from desert air is not just a dream anymore. It's a scientific reality. It's an incredible step towards solving one of the biggest challenges humanity has ever faced. And it leaves us with one really hopeful question. Are we actually witnessing the dawn of a truly water-secure world?